Heidi-ho! Let's get started on example 9. So like I said before, you guys, example 9 is pretty much the same thing. So if you want to try it on your own, and then at the end see if you did it right, I say go for it. Otherwise, follow along with Miss Long. Okay, so don't forget, you guys, when we're graphing transformations, the very first graph that we always start with is the parent function, which, remember, we always are going to use the points -2, -1, 0, 1, and 2. Okay, which when we square them, we'll get the points 4, 1, 0, 1, and 4. And again, if it helps you, remember you can write these as a point. So we have like -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. Alright, so let's graph the parent function. Remember, you guys, this is always the very first step. So your very first graph will be the same every single time we do this. Okay, so I have the point -2, 4, 1, 1, 0, 0, 1, sorry, -1, 1, 1, 1, and 2, 4. There we go, our lovely U-shaped graph, which is called a parabola. And yes, I hit all my points, so we're already off to a good start. Okay, so remember, you guys, after we graph the parent function, which value do we always tackle next? The A, H, or K value? What do you think? Well, it's always good to tackle the A value next, because later on, if you try to do the A value at the end or after you do H or K, it will be a lot more complicated. So might as well tackle the A value. Okay, so remember, each time I'm going to add one thing to my equation, and we're going to do one transformation at a time. And at the end, we'll get to our ultimate equations graph, which is this lovely equation right here. So which value in my equation is the A? Well, the A is the number right after the equal sign and right before the parentheses. So which one of these values represents the A? Holy hot dog, it would be the 1/2. Okay, so I'm going to add 1/2 to my parent function equation. So it'd be y equals 1/2 x squared. Okay, and before we talk about the points, remember, you guys are like math magicians. You can already predict what the graph will do based on the transformation in your equation. So if you have an A value, that's a 1/2. So remember, when A is not 1, it's either going to vertically stretch or compress. If A is also negative, it will reflect, which since this time A is not negative, it's not going to reflect. Okay, so the A value only reflects over the x-axis when that value is negative. Okay, so when it's a 1/2, do you guys remember, will it vertically stretch or compress? Well, when it's a fraction, your graph will always vertically compress, which if you smush down your graph, if I smush down this graph, okay, it's going to force it to expand outward because you're like smushing it down, which will mean the graph gets wider. Okay, so when it's a fraction, it vertically compresses, which will make it get wider. So I know my graph should get wider if I do this correctly. Okay, so what's going to happen in the transformation? The graph will vertically compress or get wider, means the same thing, by a factor of 1/2. Okay, so vertically compressed by a factor of 1/2. So what that means is the graph will be half the height that it was, which makes sense because the graph will kind of get wider. So the height of each point will be lower. Okay, so remember, when we get the points, okay, all I did, I copied down my parent function points. I literally just copied them down. Okay, which remember, the parent function is y equals x squared. Now when we add the A on, it's y equals 1/2 times the x squared. So I'm going to take all my y's and multiply them by the A value. So I'm going to take every single y in my parent function and multiply them by 1/2. Don't forget, you guys, leave x alone. Okay, if you try to touch x when you're dealing with A, the demon cats will be coming for you, so watch yourself. Okay, so let's come up with our points. Guys, when you're multiplying 1/2, that's the same thing as dividing by 2. You can also think about it as multiplying this by 4/1 and going straight across. So if you did that, it'd be like 4 times 1 is 4, and 1 times 2 is 2, and 4/2 is 2. Okay, so whenever you multiply something by 1/2, it's like dividing this by 2, which we did that, 4 divided by 2, right? Okay, so for the rest of them, I'm simply going to divide by 2. You can multiply by 1/2 though, it's kind of up to you. Okay, so my first point is the point -2, 2. Okay, my next point, 1 times 1/2, well 1 times anything is itself. So 1 times 1/2, or 1 divided by 2, is 1/2. So my next point is going to be the point, let's see here, -1, 1/2. Alright, my next point, 0 times 1/2, well 0 times anything is 0. So my next point is at 0, 0. Then my next one, 1 times anything is itself, so 1 times 1/2 is 1/2. So my next point is 1, 1/2. Okay, and then 4 times 1/2, or 4 divided by 2, is simply 2. So my next point is 2, 2. Get it? 2, 2. Board slapper. Alright, but anyways, let's go ahead and graph these points. So if we did it correctly, the graph should vertically compress, which will cause it to flatten out and get wider. So if we did it right, the graph will get wider. Let's see what happens. Alright, I had the point -2, 2, so -2, 2. Then -1, 1/2, so -1, then I'm just going to go up like halfway. Alright, then we have the point 0, 0, 1, and then half, so remember, just kind of go up halfway. And 2, 2. Look at that, you guys. See how the graph got wider? Look at that. The graph's getting a little lazy, sitting on the couch for too long, gained some weight, got wider, right? Okay, so there we go. So remember, you guys, the a value after the parent function, the a value is the only transformation that we make a table for. The h and the k, you can simply just move the points on your graph. Okay, so again, remember, you guys, it doesn't matter. After you tackle the a value, you can do either the h or k next. It doesn't matter. Okay, so I like to do the h value. Which one of these values represents the h? We've already done the 1/2, so that's done. Well, the h is whatever's added or subtracted to the x, which is this +2. Okay, so I'm going to add the h to my most recent equation, which is this one. So we have y equals 1/2 x squared, and I'm simply going to add on the h, which is the +2. Now remember, you guys, the h goes left and right, and we have to think the opposite with the h. So if it's a +2, the demon cats will tell you, well, +2 means a positive direction, which on the x-axis, the positive direction is to the right, and that's when the demon cats will get you. So don't listen to them. Okay, so with the h value, we think the opposite. So when it's a +2, we're actually going to go to the left 2 spaces. Nice job, math magicians. We already know it's going to happen. Yes, I'm going to go to my most recent graph. What is my most recent graph? The black graph or the pink graph? Which one represents the a value? Well, that would be our pink graph. So I'm going to take the points on the pink graph and count to the left 2 spaces. Like Beyonce, you got to go to the left, right? All right, there we go. So I'm going to start with this point and count to the left 2 spaces. So to the left, bam. I'm going to start here. Again, we're like halfway up, so just make sure you remain halfway up when you count. So I'm going to go to the left. Okay, I'm going to start from this point and go to the left. You're going to have that song stuck in your head all day, aren't you? Yep. Okay, I'm going to count this point to the left. And I'm going to count this point to the left. There we go. So there you go. Our pink graph has shifted to the left 2 spaces. There we go. All right, and our final value is the k value. So you tackle the a and the h. Which value do you guys think is the k value? Well, the k value is whatever is added or subtracted on the very end after your parentheses. So that would be a -3. Guys, so I'm going to take my most recent equation, which is this, and just add on the k value, which when I do that, you will end up with your original equation. And ultimately, we'll end up with our final graph, which is the graph of this equation. So I have y equals 1/2 times x plus 2 quantity squared, and I'm going to add on the k value, which is -3. Okay, so remember h, you think horizontal, so left to right. K, you think kangaroo, so up and down. Okay, remember though, the k value, you don't think the opposite, don't. So h, think the opposite, and I just made my screen freeze. Sorry guys, got a little carried away. Okay, H, you think the opposite, K you don't. So K, since it's minus 3, if we're going up or down, which one is the negative direction? Well, that would be going down, which the further down you go, the further, or the closer you get to the demon cat. So watch yourself. Okay, so we're going to go down 3 spaces. Alright, so for our final graph, I'm going to start from my most recent graph. Which graph is the most recent graph? The parent, the A value, or the H value graph? Well, that would be the H value graph, or a green graph. So I'm going to start from the green graph and count down 3 spaces for all my points. So I'm going to start here and count down 3. So we should be at 2, which I know I'm slightly off. Sorry, guys. Again, graph paper makes it a lot easier to do this. So I'm going to count down 3 spaces. So this should be at a 2. So when I count down, it'll be 1, 2, then 3. So right here. This point is like halfway up. So each time I count, I need to be like in between each tick mark. So I'm going to count like in between, then in between, then in between. So somewhere about right here. Okay, and then this one's going to go down 3. So to about right here. 1, 2, 3. Alright, this one again, we're halfway in between a tick mark, so each time you count, make sure you count halfway in between your tick marks. So this one's going to go half, half, half. So right here. Somewhere about right there. Again, graph paper is much easier. So if you're having trouble counting on this, I'm telling you, graph paper makes your life infinitely easier when you do this. Alright, and at this point, I'm going to count down 3. So 1, 2, 3. There we go. So our green graph, all that has happened is that it has shifted down 3 spaces. So guess what, you guys? There you go. The purple graph is our final graph, and that's what the graph of this equation will look like. Isn't that awesome, you guys? I just love transformations. They're really cool, and they make an awesome graph. And also, guys, don't forget to name your graph. So we found the A, H, and K. So lastly, let's name that graph. So my graph, I think it looks like a Cameron. My graph's name's Cameron. Make sure you give your graph a wonderful name. Well, that's it, you guys. I hope you've enjoyed transformations as much as I have, which I'm pretty sure you did, because I can already tell based on the way your faces look right now that you're loving it. So nice job, you guys.